Robinson from Norfolk. I just wanted to ask Lynn a question that relates to what he was just talking about, actually, and it relates to the speech that Webster made this afternoon, which I thought was excellent. It brought to mind when Webster was talking about Galileo and about Descartes and about Newton, the difference between Newton's conception of inertia and Leibniz's conception of inertia, which obviously Leibniz viewed as one of his major scientific breakthroughs, if you read some of what he has to write about these things. And I had always thought, I mean, the conception of inertia that you hear from Newton is essentially a conception of momentum, mass times velocity. And the way that Leibniz's conception of inertia is presented, which Leibniz called vis viva, which one would think relates in some way to life, not just to an inanimate object or to a mechanical system, is always presented as simply being an algebraic difference from what Newton said, namely mass times velocity squared. And I was just wondering if, I think that Leibniz was actually talking about something more profound than that and something closer to what Lynn has been talking about, and I just thought he might want to comment on it.
All right, very quickly. First of all, reference to Riemann on 2 counts in the Fidelio paper and other locations. Number 1, the key thing to understand what I understand. 2 things. First of all, from the standpoint of Riemann, Riemann's paper on hypothesis is the most important paper in physical science since Leibniz. Start from there. This has 2 aspects. One aspect is the so-called continuum paradox, which is what I referred to primarily here in the past days. No mathematics can represent the universe. No known classroom mathematics can, by extension or calculation, accurately describe or define the processes of causality in this physical universe. Cannot be done. The reason is let me just, this is the last question, so I'll just get this thing clear, just to make sure I'm not confusing people. A physics which cannot account for the existence of the physicist who has made the discovery in physical science is not a competent physics. B, that's 1. B, physics as a practice, valid physics, is a result of discoveries which are creative, and because they are creative, they violate axiomatic structures. Now, no axiomatic system can represent from a system of what is called a lower cardinality a direct logical access to a system of a higher cardinality. Cannot be done. There is a gap which is called discontinuity. This gap is of virtually 0 dimensions, but it's existent. This gap corresponds to thought, to creative thought. This gap shows up in physics and in mathematical physics as what is called the continuum paradox effect. And no mathematics, therefore, can represent that. Now, the fact that the physicist exists in the universe signifies that the universe is organized in a way which is coherent with the existence of the physicist. You cannot have a universe which contains people who could not exist in that universe. Therefore, if the physicist exists and he's creative and he has this continuum paradox, therefore the universe has this continuum paradox. For which reason Riemann says at the end of this paper, when you consider this fact, you next must leave the Department of Mathematics because you can do no more business there. You must now go into the Department of Physics. Second, the second thing, and this was very clear to Leibniz, and Leibniz's monadology is a reflection of an understanding of precisely this continuum paradox, as I've treated this in papers on metaphor. Second, the second area here to consider, which pertains to the implication of the vis viva. in a broader sense, is that what Riemann refers to is something that was misunderstood by Einstein. Einstein read the Riemann paper on hypothesis, particularly part 2 on the application to space, as signifying that Riemann and Gauss believed in a spherical geometry of an unbounded space-time, which is finite but unbounded. That is wrong. Riemann did not restrict himself to a spherical space-time. Secondly, the space-time is bounded. It's bounded by higher considerations. Secondly, whatever the curvature of space-time proves to be, that's the curvature. It is not. You start from a spherical space-time notion of reference, as in Gauss's work, but they're not limited to that. So therefore, the vis viva, the significance of that, shows up with the work of Riemann, that we're dealing with a problem of the curvature of physical space-time, which we can measure. But to define the curvature of physical space-time, we cannot use generally accepted classroom mathematics, because you're including a form of mathematics which must take into account the implications of the continuum paradox, which means you leave the transcendental domain and you've now come into a higher domain, which is the domain of the so-called Alice series of Cantor, at least symbolically. That's the kind of problem. So Leibniz is already aware of some of these problems at the time he's making this treatment, and when we look back from the standpoint of Riemann and what flows from Riemann and look back at Leibniz from that standpoint, we understand Leibniz in some sense better perhaps than he understood himself.